The success of 360 Y-drop as a management practice hinges on two primary agronomic factors: timing and placement. We're taking advantage of both of those by moving our nitrogen to a Y-drop application. The agronomics of Y-drop all start with me around the nitrogen uptake chart. And this is a chart that we've referenced for years. It was foundational in understanding when the crop needs its nitrogen and how it takes it up and where it goes. So as we look at a chart like this, we can see we build this graph over time. So we have the growth stage of corn across the bottom, also rough growing degree days. And then along the vertical axis, we've got percent of total nitrogen uptake, or roughly in pounds, along the other side. So most commonly we see as corn emerges at the VE stage, vegetative emergence, it uses very little nitrogen for the first period of its life until it gets to about that boot high stage when it's at V5 to V6. That's when the nodal roots emerge from the crown, and those are the heavy nutrient feeding tubes, heavily on nitrogen. And you can see the slope of the curve take off vertically once we get to that growth stage. At that point in time of the corn's life, it's hard to over-apply the amount of nitrogen that it needs, but that is where the timing advantage of a Y-drop application comes in. If you look at by the time we get to head-high corn, V8 to V10, the last chance you'd have to cross that cornfield with a conventional height self-propelled sprayer, we're only around 25% of the total nitrogen being taken up. So we need to plan on topping the tank off, and if we're not seeing 3/4 or more on the gas gauge, we know we're going to run out by the end of the race. So that's the timing benefit of having higher clearance equipment and utilizing 360 Y-drop, the fact that corn uses a lot of nitrogen later in its life. One of the other critical agronomic aspects of a Y-drop is the placement of the nitrogen relative to the row. So traditionally, we have placed nitrogen in the middle of the corn rows 10 to 15 inches away from the base of the stalk, because we always were trained that you needed to put that nitrogen into the ground to protect it from the environment. And while that is true, keeping it out of the sunlight and out of the air helps reduce some of the losses. We've learned the shortcomings of that system are that nitrogen does not spread out side to side to come into contact with the root system. As evidence here in this grass strip where we applied nitrogen in strips, the grass only got green about 4 inches wide. The nitrogen did not reach out and spread out across the surface and get into where we would like to see the rows of corn. So as a corn farmer, you can look at that and say, where would I want to place my nitrogen relative to my rows of crop? And the answer is very clear when you look at this example. Traditionally, people have been hesitant to apply nitrogen on the surface of the ground because of the risk of volatilization loss. We know that 78% of our atmosphere is actually made up of nitrogen gas, and that product that we put on the ground, the fertilizer, will volatilize back into the atmosphere under certain conditions. What allows the Y-drop placement to work is what we call stem water. And it's something that farmers have known for generations. The way the corn plant is structured, it funnels water down to the base of the plant. We proved that here in this example by putting PVC pipe caps around the base of the plant during a rainstorm. We measured 8 times as much rainfall at the base of the plant as we did 15 inches away in the center of the row. And it's obvious once you dig a soil pit and look at the moisture profile across that. When you're over in the middle of the row, we have just not even an inch of penetration. But when you go to look at the root mass, where all the feeding on nutrients and nitrogen happens, that whole root mass is soaked in wet dirt from the magnification of stem water. So even a heavy dew will drip down with gravity and drive nitrogen placed at the base of the plant into the root system. And that's a true competitive advantage of 360 Y-drop. Even at the high operating speeds of self-propelled sprayers, we're always pinning that nitrogen right at the base of every stalk, and that's critical to the success of surface applied nitrogen. The yield results have been proven out time and time again, and they're available on our website at 360yieldresults.com. But here's one of the more comprehensive plots we've ever seen, done by the Iowa Soybean Association across 6 different locations. They applied the same rate of product on the same date by 3 different methods. The first was liquid nitrogen UAN with a coulter. The second was UAN via Y-drop, where we had an 8.5 bushel gain over the coulter. And the third was broadcast pelletized urea, where the Y-drop had a 25 bushel gain, again applying the same amount of product on exactly the same day. So the placement and timing advantage of Y-drop becomes very clear when you look at this 6 location summary plot. The other main competitive advantage of Y-drop is the fact that we're now banding nutrients where we used to broadcast them. In today's high nitrogen price environment, where growers are paying over $1 a pound for nitrogen for the first time in their farming career, if we can make even a small percentage improvement in your nitrogen use efficiency, that equals a tremendous amount of dollars. So traditionally, we were taught that it takes 1.1 pounds of nitrogen to grow a bushel of corn. And that's true. That is what the corn plant takes up. That doesn't mean that's what we need to apply as growers every acre every year. If we can make the nitrogen system work for us and rely on the nitrogen supplying power of our organic matter, we can move our use efficiency number down, and we'd love to see growers in the 0.7 club, where there would be a 37% improvement, meaning 37% less nitrogen used, purchase that you had to pay for. In return, that saves you 46 cents on every bushel. So if you can move from a 1.1 guy to a 0.7 guy on the nitrogen use efficiency, that's like a 46-cent premium on every bushel that you sell. That's where the power of banding, the power of timing, and placement of a 360 Y-drop system comes home.